Dear participants, welcome to the second session of Day 3 Room 1 presentations. In this session, we are hosting Professor Eko SISWOYO from the Islamic University of Indonesia, Professor NIHAL BEKTAŞ from Gebze Technical University, Turkey, Professor ADARSH from TKM College of Engineering, India, and Dr. AIDA HOSSEINI from Tabriz University, Iran. Welcome, professors. Firstly, I would like to invite Professor Eko SISWOYO from Indonesia to deliver his presentation.
Okay. Good afternoon, Professor Mustafa.
Good afternoon, Professor.
So should I start now? Okay.
Yes, you may start.
Okay, let me share screen. Just a moment. So, could you see my PowerPoint?
Yes, we can see it, Professor.
Okay, thank you so much, Professor Mustafa. Okay, good afternoon, ladies and gentlemen, and maybe good morning in other side of the world, because in Indonesia, no, in Yogyakarta is 4:30 p.m. So I'm very honored to be here to share our research. And in the beginning, I would like to thank so much for organizing committee for giving me a chance to stay and participate in very great conference. And then today I would like to talk about the environmentally friendly adsorbent for removal of heavy metal ions in water. So my name is Eko SISWOYO. I'm from the Department of Environmental Engineering, Faculty of Civil Engineering and Planning, Islamic University of Indonesia in Yogyakarta. So within about 30 minutes, I'm going to talk about the background of our study, the material and methods we use during our study, result and discussion, conclusion and acknowledgement. Okay, so everybody, maybe I would like to start with a very, I think, interesting question. So do you have a problem of water contamination in your country? I guess that even people living in developed country, maybe you still have experience with the water contamination. And then in Japan, so actually I live in Japan for about 6 years during my master and PhD, and then I got some issue over there that they have the Minamata disease, very serious environmental problem, the contamination of the methyl mercury in the seawater, and then Itate disease, or in Japan we call Itate bioing, and then it is contamination of cadmium ion in water, and then I tried to search the heavy metal contamination in Turkey, and then from I think a recent journal in the Chemosphere, I found that the concentration of chromium and lead ion in Sinop province soil, Turkey, up to 761.36, and for chromium, and then for lead is 54.64 milligram per kilogram. It is by BEKTAŞ et al. 2020. It means that we already have the experience the same condition for heavy metal contamination in Indonesia and in Turkey. So let me look at this another slide. So what in Indonesia, in my country, so you can see from this slide that we have a serious heavy metal contamination from the industrial. You can see from this figure that the river water become black and also become very colorful. But unfortunately, it is the waste from the textile industry. And then look at this this one. It is the effluent from for the wastewater treatment plant. And then sometime the industry or the company, do not operate their wastewater treatment plant properly. They want to reduce the cost in operation costs. And then you can see in the right side, you can see the pipe. So what kind of pipe this one? So in Indonesia, we call pipa siluman or air-fill pipe because we cannot see this pipe all time, only in the specific time, and then this pipe will present. I mean that sometimes the industry they dispose the wastewater directly to the river or other water bodies, but sometimes they what is put up this pipe, so this pipe disappear anytime. And then the look at the some problem. So lead and copper in the sediment taken from Jakarta, our capital, is up to 6.9 and 4.1 milligram per liter. And then also cadmium in some freshwater fishes in Indonesia also is up to 0.06 milligram per liter. And then the water quality in most location in the upper Citarum River in West Java is very poor. And why it is very important to develop a low cost system? I mean that the problem is because the limit of technology and budget for wastewater treatment plant. So why some contamination, many contamination is present, especially in the developing country. So it is very important if we can develop a low cost technology, and in this time we call low cost adsorbent. And then we know we have the environmental contamination, but the most important thing is how to solve the problem of environmental contamination. We know some method, it's like the ion exchange, high efficiency, but I think expensive and also need high skill, especially again for developing country. It is very complicated. And then phytoremediation, we know that it is very cheap and easy, but the process is slow and need to treat the plant after the process. So some biologists they say that there is when we use the plant to absorb some metal ion, for example, and then what should we do with the plant? So we should do another treatment. We have to treat the contaminated plant, I mean. And then the filtration, even membrane technology, and then reverse osmosis, I think the advanced filter system, it has high efficiency, but very expensive, I think, and also need a high skill. And then what about the absorption? High efficiency, easy, but the current adsorbent is I mean that the current adsorbent, we usually use the activated carbon. It is quite expensive. So what we need is we need the adsorbent material with the high efficiency, easy in application, but low cost. And then also the most important thing is the local material should be available. So the adsorption with low cost adsorbent is the best solution, I think. And then so for the low cost adsorbent in this study, we use the paper slag. I mean that the waste from the paper industry. So around 5 million tons of paper slag are discharged annually as solid waste in Japan. It means that the company in Japan they dispose the paper slag and then to the landfill. They have to treat, and then of course need the money, need the budget to treat the paper slag waste in the landfill. And then the paper slag and other organic waste material from paper industry could be considered as a material of adsorbent due to their high carbon content and cellulose fiber proportion. And then the application of paper slag as adsorbent for absorption of metal ions is still very limited. So why I select the paper slag as the adsorbent material in this time. And then how to prepare the adsorbent, it is very simple. So from the raw paper slag waste, we wash with the water, distilled water, and then dry it at 100 Celsius degree for 1 day in the oven, and then kept at the room temperature for a day also, and then crush and shape into powder form. So the paper slag waste is ready to be utilized as the adsorbent material. But in this study, we try to improve the absorption capacity of the adsorbent. So we use some chemical. We know that we can use some chemical in order to improve or in order to increase the performance of the adsorbent. So in this time, we use the phosphoric acid to activate or to increase the absorption capacity of the paper sludge as adsorbent material to absorb the cadmium and lead ion in water. And then, so it is very important to know the mechanism. So why we do some characterization process? We use the elemental test, we use the SIM EDS, and then also BET in order to know the surface area of the adsorbent. And then ICP-MS we utilize, and of course we use FTR in order to know the functional group of the adsorbent material. And then how to operate the absorption process, how to do the process of absorption. We still we're using this one, and then centrifuge after the after shaking, and then we centrifuge or we filter, and then we analyze by using AS. And then it is our finding that the characteristic of the paper sludge, raw paper sludge, the pH is very quite high pH, and then the surface area is 50, not so big, I think, compared to activated carbon. And then it is the based on the elemental analysis, we can see that the paper sludge, the most component is carbon, and also this one. And then it is the surface, the morphology of the paper sludge based on the same data. And then when we activate by using the phosphoric acid, the surface area increase almost 2 times. And then when we use this paper sludge to absorb the metal ions, cadmium and lead ions, we can see this data that it is in different pH. The absorption capacity is also different. Of course, because it is very important. The pH is very important. It influences the absorption capacity very well. And then it is for the cadmium, and then it is for the lead. We can see that it is in pH 5, the efficiency only 40% before activation. But when we activate by using the phosphoric acid with the different impregnation ratio, I mean that we use the different concentration of the phosphoric acid, and then we can see this one. So the ratio 0.5, it is the best. So the absorption capacity for both cadmium and lead ion is more than 90% for the 10 ppm of the initial concentration, and then for cadmium ion, and then for the lead ion, the initial concentration in 50 ppm, and then the removal capacity is almost 100%. I think it is 95 for lead, and then 90 something for cadmium ion. It means that the activation by using the phosphoric acid is very important in this case. And then look at the SEM data. It is very difficult to identify the effect of activation by using acid solution only by using SEM. But maybe we can see from this data the surface area of treated phosphoric acid paper sludge by using phosphoric acid increase almost 2 times. So from 50 to 83.5 milligram meter square per gram. And then is the FTR data. We can see that this paper sludge has some functional group. Maybe in this part, maybe we can see that maybe this one is equal to carboxyl group, and then also in this peak, the strong peak at the 1080 indicate the presence of phosphate group as effect of treatment with phosphoric acid. You can see this one. Okay, and then again, we try to apply this activated paper sludge with different pH. Again, that the after activation, the paper sludge or this adsorbent work very well. So we can see that it is in the pH 5 for lead ion, it is before and after activation. So it's been improved the activation very significant. And then for the cadmium ion also, so in the pH 7 and 8, it is maybe almost same, but in the low pH 5 and 6, the effect of the activation is very clear. Yeah. So as we know that the pH is in the alkali condition, so I mean that in the acidic condition, this the surface of the charge of the adsorbent will be protonated. I mean that the adsorbent material has the positive charge. And then when we use to adsorb the metal ion as like the cadmium or a lead ion with the same charge, positive charge, so why in the acidic condition it is not good, but after activation, so it is improve the performance of the adsorbent. It means that the adsorbent by activation with phosphoric acid has the wide pH range. And then this one, it is taking time also. This adsorbent work very fast, so within 15 minutes, it is the absorption capacity is like this one. So I think almost the same. It is more than 90% the absorption capacity, and then this one also for both lead and cadmium ion. So we use in different initial concentration. This one, so you can see both 10 ppm and 100 ppm for lead ion. It also already very fast within 15 minutes to 30 minutes. The adsorbent work very well. And then what about the isotherm absorption? So by using the Langmuir model, we can determine the absorption capacity of the adsorbent. We can see that for a lead ion, the adsorbent performance is up to almost 140 milligram per gram. It is very good, I think. And then for the cadmium ion, almost 30 milligram per gram. I think it is also high enough when we compare to other adsorbent material. So in this study, we use the powdery paper slat. And then it is the kinetic, we can see this one. And then it's, the mechanism. So it is very important to know the mechanism of absorption. So we try to use as we know that we expect that the phosphoric acid is influence the absorption capacity very well. So we use it's like the calcium carbonate like this without activation. So it is the similar. The form is like the clay, and then when we activate by using the phosphoric acid with the impregnation ratio until 0.5, and then the absorption capacity increase almost 3 times, I think, more than 3 times, from 16 to 56. It means that the presence of the phosphoric acid, it's like the phosphoric functional group in the adsorbent from the phosphoric acid solution we use as activation agent take important role in the absorption process. And then anyway, so when we use the powdery activated carbon, activated slat, I mean that we need more effort because after the absorption process, we have to separate the adsorbent material from the solution. We need a filter or we need decantation and so on. So why we try to develop another kind of adsorbent material, and you can see we call this one as encapsulated adsorbent. We use some alginate gel and also agarose to bind our adsorbent, and then we make some different kind of adsorbent form. So from it's like granular like this, and then or block like this, and then also fiber. So this one is my recent focus in the fiber adsorbent. So look at this one. So when we use the powdery adsorbent, again you need a filter. But when we use the granular or maybe fiber adsorbent, after finish the absorption process, we just pick up the adsorbent. It's very easy. So why we suggest to use the fiber adsorbent. And then it is just published about 2 years ago. And then it is the same after activation also. We use another kind of adsorbent material. You can this one. Maybe I will directly. And then it is the raw sludge. It is the metal ion in the sludge. It is from the drinking water treatment plant, drinking water treatment plant sludge. And then mostly is aluminium, because you know that the drinking water company, they use the coagulant, maybe aluminum sulfate and so on. And then it is the effect of the dose. We use different dose or different mass of adsorbent, and then of course by increasing the dose of the adsorbent, and then the capacity also increase. And then this one also the effect of pH. So the fiber adsorbent work very well. So it is, you can see this one is very well. And then the time is very important. So we can see in this figure that of course by using the powdery adsorbent, it was very fast, maybe within 15 minutes and so on. But when we use the encapsulated or in the fiber adsorbent, we need a longer time, because you know it is because the surface of the adsorbent may be covered by the some, I mean that the agent we use to encapsulate the adsorbent material. So the adsorbent work a little bit slower. So in this time we are focusing on the how to get the adsorbent with the fast adsorption process. But even here we can see that within like 30 minutes the adsorption capacity is already more than 90%. So it means that even the powdery adsorbent is work faster, but fiber adsorbent also work is not so bad. I mean that because already 90%, more than 90%. And then if it effect of the initial concentration, you can see that is even in the 300 ppm, and this adsorbent still work very well. And then this one is the Langmuir. And then let's see this data that by using the fiber adsorbent, this adsorbent work for this one is 40. So it is good for adsorption process. And then the last data, it is unpublished data that we can develop the adsorbent material, the fiber, with the very high adsorption capacity until 178 milligram per gram. So I think it is very good. And then the mechanism is like this one for the cadmium ion, because in the adsorbent there is some carboxyl group. So the carboxyl group from the adsorbent will this one, they will bind the metal cadmium ion. So COOH, and then it will release and then change to cadmium. Why? So the adsorbent can adsorb cadmium ion very well. And also I think the same thing for the lead ion. And then also in this time I want to show you we also develop the adsorbent based on the C cell waste. And then also the data so that by using the heating system, and then the adsorption capacity also good, I think. This one. So by heating on 500 Celsius degree, and then the adsorption capacity more than 90%, the removal for the cadmium ion. And then again, the pH take very important role, because in the acidic condition, why in this acidic condition the adsorbent not work, because in the acidic condition the adsorbent surface protonated, so the positive and positive will be repulsion. And then but after pH 6 the adsorbent will be very good, I think. pH neutral 7 is more than 90%. So I think we can adapt this adsorbent for the water. I mean that for the remediation or for treatment of the contaminated water by heavy metal ion, especially with the cadmium and lead ion here. This one. And then as a conclusion, so the ability of plain paper sludge was not so high, but by activation with the phosphoric acid, the adsorption capacity increased very good. And then the quick adsorption process and high adsorption capacity of the adsorbent should be considered as a low-cost adsorbent material for cadmium removal in the real application. So the application of this material will give some benefits, such as reducing amount of solid waste in the landfill. It means that we can cut the budget for the treatment of the waste in the landfill. So and then decreasing cost, and then also in the same time we can provide the low cost and environmentally friendly adsorbent because we can reduce the number of the waste. And then in the end of my presentation, I put the photo of the mosque, very popular mosque in Turkey. I think it's also very popular in Indonesia, Hagia Sophia. And then I really hope to visit Turkey soon in the near future, maybe after pandemic. I hope. I think that's all my presentation. So my research is supported by the Indonesian Ministry of the Research and Higher Education, or in Indonesia we call Ristek Dikti. And then it is our campus, environmental engineering in Yogyakarta. I think very green campus. Sorry, I put this logo ABET because fortunately, maybe since 2016, our department accredited internationally by ABET in USA. I think that's all my presentation. Thank you so much.
Many thanks to Professor SISWOYO for his valuable presentation about the wastewater management. We would be happy to welcome you to Turkey anytime, Professor SISWOYO.
Okay, thank you so much, Professor Mustafa.
Thank you. Our second valuable guest is from Turkey, Gebze Technical University. Welcome, Professor BEKTAŞ. The stage is yours.
Okay. Thank you. Thank you, Dr. Alas. Yeah, Dr. Alas. Thank
Hello,
you for
Professor.
this,
Welcome.
Short, little nice introduction to me. Here's my screen. Here. Share. Oh, sorry. Share screen. Okay, you can see my presentation now?
Yes, we can see Professor BEKTAŞ.
Okay. Right. Before I start my talk, my presentation, I would like to thank the organization committee, especially Professor Gökçe Kuş, for organizing this interesting and useful conference. It has been very good and interesting conference. Thank you very much for giving me this opportunity to take part in this congress. My presentation is about the municipal solid waste management with zero waste approaches, of course, in Turkey. I prepared this presentation with my PhD student, Ms. Serpil Öztaş, who also study on the same subject. My presentation plan is follows. Since my title of the presentation is about the solid waste management, especially sustainable solid waste, municipal solid waste management, I will little bit talk about the term of the sustainability, little bit definition of the sustainability, and then I will talk about solid waste management. Then I will give little more information on circular economy and zero waste management, and I will conclude my presentation. What is the sustainability? Sustainability, just let me. Sorry. I would like to see myself as well. I'd like to adjust my screen. In original definition, sustainability can be defined as meeting the needs of the present without compromising the ability of the future generation to meet their own needs. This definition has been changed more recently, and sustainability nowadays can be defined as a dynamic process which enables all people to realize their potential and to improve their quality of life in ways which simultaneously protect and enhance the Earth's life support systems. Therefore, as you can see, sustainability shouldn't be more than a just buzzword, and it's more than just environmentalism. Sustainability, therefore, based off a simple principle, everything we need for our survival and well-being depends either directly or indirectly on the natural environment. Therefore, while protecting the environment is a part of the sustainability, that is not where the sustainability ends. The concept of the sustainability also covers economic development and social equity. To pursue sustainability is to create and maintain the condition under which humans and nature can exist in a productivity harmony to support present and future generation. As you can see from here, the sustainability is not only linked with the environment, but also with the social and economical environment, forming the three pillars of the sustainability that aims to guarantee to planet's ability to improve the quality of life. As you can see from here, over the years, the idea of sustainability has been referred to people, profit, planet, or the triple bottom line, emphasizing the fact that all three types of the sustainability are important and should be balanced. However, the sustainability has been also changed. We have to move to different type of the sustainability. We have to move toward the strong sustainability. What is the strong sustainability? Strong sustainability can be defined as the three concentric cycles that further emphasizes the interdependence of the three dimensions. Environment is the primary importance because a healthy ecosystem is required to provide a strong society. Society and social responsibility are the secondary importance. The economic sustainability is third because a prosperous economy cannot exist without a healthy, just society and environment. Why I put these slides here? Because we need to understand how modern society develops. It's useful to distinguish societies according to their type of economy and technology. As you can see here, the humanity start with the hunting society at the birth of the human, and then agricultural society comes, and then industrial society can be seen end of the 18th century, and then the last century, end of the last century, the society has changed to information society. Nowadays, we are talking about the different concept. We are talking about super smart society from the 21st century. Industrial societies are based using the machines to produce goods. Industrializations brought about the changes almost very aspect of the society. Society 5.0 attempts to balance economic development with the resolution of the societal and environmental problems. In order to remain the engine of the prosperity, industry must lead digital and green transitions. Industry 5.0 brings the benefit for industry, for workers, and society. What industry or society 5.0 wants? In the society 5.0, the people in this century wants more sustainable, resilient, and human-centric industry. This is important because the type of the society has changed, and the technology is improving. The super smart technologies has been very powerful at our life, but to use this powerful technology, we need human and healthy environment. Therefore, sustainable, resilient, human-centric industry is becoming important in this century. So how can we? I'm an environmental engineer. I forgot to tell at the beginning of my presentation. Work Gebze Technical University at Environmental Engineering Department. Therefore, I put these slides because the definition of the environmental engineering has changed. It has to change, I should say. Environmental engineering works to improve ecosystem health, manage the pollutions, and conserve natural resources. However, environmental engineering has grown since this century by replacing the older style engineering with a new style that makes ecology a priority. Environmental engineering's future seems boundless because it based on many ways in which nature solves its own engineering challenge. Now we talk a little bit. We start to talk about a little bit solid waste because my presentation is about the municipal management of the municipal solid waste. The simple definition of the solid waste is I would like to do the simple definition of the solid waste. We can define the solid waste as a solid or semi-solid substance generated as a result of the human activities or process and being no longer of the economical value, or we call it unwanted or useless materials. However, these materials aren't functioning anymore to you, but it may be useful to another person or process. Therefore, waste definition has to change to something else. Therefore, as you can see here, if you say waste with this definition is determined by how the owner sees this item or how much it values. A material that is waste for one facility or person may not be waste for another. These definitions, these things very important in a sustainable sustainable management of our solid waste. Solid waste is not only technical problems, as you can see here. A problem is organizations, a problem is of educations, a problem of industrial design and responsibility. Therefore, elimination waste is the key stepping stone in the moving the throwaway society to a sustainable society. I would like to give the definition of the solid waste management here. We can define the solid waste management, especially municipal solid waste management, includes all administrative, financial, legal, planning, and engineering functions related to solid waste problem solutions. Managing municipal solid waste is challenging because it's heterogeneous natures. Why we need effective waste management? We need effective waste management to protect environment, to ensure the economic development, to reduce the potential impacts of the future generations. And we have to do it in a sustainable way. Why is this solid waste management is sustainable? As you can see from this apple, we already finished the apple, but we can't see it. We only see the full apples on the mirror. This is our dilemma. We forget about we live in an infinitive world, but behave as if it's there inexhaustible, never finished. But we already started to finish our resources. Therefore, sustainable solid waste management is vital to conserve valuable natural resources, to prevent the unnecessary emission of greenhouse gases, to protect public health and natural ecosystems. Effective municipal solid waste management should be therefore, effective solid waste management should be both environmentally and economically sustainable. Environmental sustainable should be environmentally sustainable by reducing the environmental impacts of the solid waste management. Economically sustainable should be operate at a cost acceptable to the community. Since, as I already told you, since municipal solid waste can have economic value, a new economic sector related to waste should have been formed. The concept of the waste economy in the world, also in Turkey, has emerged not only to protect nature, but also to contribute to the economic cycle. As you can see here in these pictures, landfill or dumping waste in open areas are the evidence that we are doing something wrong. These are not rubbish, or these are not unwanted material. These are our raw materials. Therefore, we need to face this real problem. In terms of the solid waste management, we have different questions, different importances at the different times. In last century, 20th century, is waste management. We always ask this question: how can we remove waste without damaging our health and environment? In this century, the key issue was safety. In this century, we have to look at the resource management. How the question should be: how do we evaluate our resources so that the future generation are not deprived of the existing resources? How to turn our waste into the resources? The important question is this. Here, the key issue is the sustainability. So we have to change the way we look at the municipal solid waste. As you can see here, if you do the sustainable solid waste management, we get three different benefits. In financial benefits, the management of waste is as an important source of income that should be evaluated, while reducing the administrative expense also enables them to be evaluated as a surplus income. The budget allocated by the cities for the management decreases, and it provides an opportunity to transfer them into two different sources. In social evaluation, dissemination of waste is prevented, and thus infection diseases are reduced. The factors that threaten the health of humans are living things are reduced. Generation are raised. Who approach the environment with the more sensitive consequences and are aware of the future danger. In this way, the probability of the living together socially in prosperity and happiness increases. In environmental assessments, reducing the damage to nature and the environment on the global scale, such as reduction of the chemical pollution, greenhouse emissions, photochemical ozone gas emissions, and locally, such as less acidification, less ecotoxicity. Here, I would like to give a little bit information about the circular economy, because if we do the sustainable municipal solid waste management, we have to convert our, we have to change our the way of the managements from the linear economy to circular economy. What is linear economy? In linear economy, raw materials, natural resources are taken, transformed into the products, and get disposed of. The line is like this: take, make, consume, throw away pattern. In circular economy model has the intention of the redesigning the wastes. In fact, a circular economy based on the idea there is no such a thing as a waste. In order to achieve this, products are designed to last and optimize for a cycle of the disassembly and reuse that will make it easier to handle and transform and renew them. There is a new perspective and approaches turning waste into the resource and including it the production process in environmental economic approaches. In economic approaches where the value of products, materials, and resources is kept in the economy as long as possible, the amount of waste is minimal. It means closing the production consumption waste management line. You have to close it, which has begun to ban by circling it. Waste prevention, reuse, recycling, recovery, including materials and energy, enable society to get maximum value from their resources, and adapt consumptions to real needs. Here you can see some of examples of the waste raw materials. As you can see, you can get fiber, cloth fiber, textile fibers from plastic bottles, waste plastic bottles, also clothes, jeans. You can see the denim jeans here. You can get fiber from here. Also, you can get an isolation materials for the houses. Also, another example is the waste raw materials is the leftover food. You can mix and dry, and you can make feed for street the animal food. The another example is the you can get recycle solid dry fuel from the recycling materials inside the solid waste. What does circular economy to your environment and economy? It makes a significant contribution to the need of the raw materials and productions. While the waste materials are brought back to the economy by recycling, the cost of the transportation, storage, and disposal is reduced, reducing the waste amount going to the also the amount of the waste going to the landfill can be reduced. When the rest turn into the raw materials, the number of the raw materials that need to be imported from abroad also reduced. You can save the energy. When you are saving the energy and raw materials, you can get more competitive. Your competitiveness increase. Also, if you produce new products from your waste materials, you can get new products for your customers, recycling new products for your customers to prevent garbage from becoming a problem, especially crowded and densely populated areas. Recovery provides a different line of work in addition to reproductions, employment. Also, the employment opportunities increase and unemployment decreases. This is very important these days. Green jobs opportunities. How can we support our how can we support circular economy? How can we support our municipal solid waste management using the circular economy? We can separate, we can collect separately our waste at source and sending them for recycling. It's important. In many developed countries, they already collect their municipal solid waste separately at homes. But in Turkey, we just started doing these now these days. We can evaluate the organic content of the waste. We can make it ready for reuse. We can make our decision makers or municipalities or private institutions can increase the number of the processing plants. These plants can use the industrial plants can use the waste materials instead of the natural resources. We can use a supplementary fuel, waste dry fuel. We can our private institution or our governments can install facilities such as biogas and gasifications. The designing is important. We have to design products suitable for recycling. Also, we have to develop sales strategies for business. Last of all, we have to recognize the zero waste policy philosophy as a lifestyle. In 1915, the United Nations published the Sustainable Development Goals, a planned action for people, planet, and prosperity. Targets has to be done by 2030. There are three different sustainable development goals related with the solid waste management. In goal 11, sustainable cities and communities. The goal says by 2030 we have to reduce the adverse per capita environmental impacts of the cities, including the paying special attention to air quality, municipal and other waste management. Also, there are two different goals at the goal 12, responsible consumption and production. So we have many tools so we can achieve sustainable municipal solid waste management. Now I want to talk about a little bit zero waste project initiated in 2011 in Turkey. It aims to control and upgrade our waste collection systems under the Sustainable Development Principles, leaving a clean Turkey and a livable world to future generations. In this project, zero waste is a goal defined as a waste management philosophy that involves preventing the waste, using the resource more efficiently, reviewing the reason for the waste formation, preventing and minimizing waste formation, and collecting and recovering waste at source separately. It is important. We have to collect and recover the waste at source separately. This is some steps given in this zero waste regulation. There are 7-step roadmap developed by the Turkish Environment and Urban Planning Ministry, consisted of the various steps that the companies, institutions, or organizations should apply to be included in the zero waste movement. What can zero waste do in our life? Zero waste can adapt us to sustainable lifestyle and encourage them to change their lifestyles in this direction. I hope. Zero waste can reduce the waste generations at home, increase the reuse and recycling. Zero waste approaches can control storage of non-recyclable wastes. Zero waste can ensure the good coordination between solid waste management sectors. Solid waste create available financial systems for customers, private enterprises, and local authorities. Zero waste can provide employment with job security, valid wage systems, and so on. Actually, I would like to give a little bit numbers here. Recovery rate of the municipal solid waste, which was the 13% at the beginning of this project, 2011. 13% of we already in 2011 we only collect 18% of our municipal solid waste separately. We can recover that. And then this number reached up to the 19% in last year, 2020. I forgot to write that. And it's planning to increase the recycling rate 35% until the 2023. We have to apply this zero waste philosophy to our life, and we have to increase our recycling rate immediately. This is the current waste collection system in Turkey. We have a tandem separation systems at home, office, and schools. Recycle bin and others waste here, and then you can find in this information anywhere in the regulation. These are the advantages, some advantages of zero waste approaches. There are many advantages legally, socially, economically, environmentally. As I already told you, there are many advantages, many good points of the separate collection of the municipal solid waste, sustainable management of the municipal solid waste, as you can see here. I already told these slides before, but if I summarize, we have to support sustainable municipal solid waste. We need to consider circular economy approaches. We need to create a collaborative working environment. We need the take waste care. People should explain that waste is not on waste is our own natural capital, and there are many advantages if we recycle this waste. As a conclusions, we should consider environmental, society, and economy as a whole. We should get sustainable waste management plans. We need a developed high efficiency process systems, technologies for reducing the environmental impacts. For example, we can develop a software model for that includes technological, environmental, and social criteria for municipal solid waste selection in a residential area. There are many tools for sustainable waste management. Zero waste approaches and circular economy are some of them. We have to increase the training and awareness activities, increasing the R&D studies and motivation in this field. We have to contribute the correct and effective use of the resource by targeting the circular economy, not only seeing it as a recycling and saving it, but also creating new business opportunities and income sources, as well as leading the spread of the new financing models. It should be seen as an opportunity to protect more livable world for all living things. Right. Contrary or popular myth, we need to understand that we more consume, the happier we'll be. The population is not, the manipulation is not valid. On the contrary, the more we consume, the more we feel desire to consume more and should feel unhappy about it. We have to save the earth. We have nowhere else to go. The big things. I conclude my presentations here. I would like to thank you all for listening. If you have any questions, I can.
Thank you very much, Professor Nihal, Professor Dr. Nihal BEKTAŞ, for making strong points on very critical issues regarding sustainability and waste management.
Okay, thank you.
I guess you have some questions to Professor SISWOYO?
Yeah, I did. Is he here?
Yes, he's waiting for us.
Oh. The low cost adsorbent is very interesting subject. I have studied the low cost adsorbents myself here, but the problem is the application of these low cost adsorbent at industrial scale. What's your situation? Have you used your low cost adsorbents at industrial scale for the real wastewater treatment?
Okay. Okay, thank you, Professor Nihal. So actually, we just applied this adsorbent for the low, it's like a small scale. So we do in our laboratory. In our laboratory, it means that we can reduce some metal in the laboratory waste. Yes, we know that it is for the real industry, not yet. But we are going to, it's like, develop, if we can find the more stable the adsorbent, and then I think we can try for the industrial scale. But it is, again, it is still in the lab scale. I mean that we just applied the adsorbent to treat our laboratory wastewater, because in our laboratory we produce the wastewater, and then wastewater also contains some metal ions.
Okay.
I think that's
okay. Thank you. So we can work together here. You can visit our laboratory in Turkey, in Gebze, near Istanbul. I write my email address here, so we can contact each other. Okay.
Thank you so much. Very, very happy to hear from you again. Okay. I really want to visit Turkey because Turkey is my favorite country also.
Okay. We
Right.
can.
Okay. Thank you so much, Professor Nihal. Thank you, Professor Mustafa.
Thank you, professors. And I'm very glad to see that we can make some collaborations together between Malaysia and Turkey, North Cyprus, Iran, India. It's very nice to see that the aim of the conference is reaching to its goal. Okay, thank you very much, professors. Now I would like to invite Dr. AIDA HOSSEINI from Tabriz University, Iran, to deliver her presentation. Dr. AIDA. I think Dr. AIDA is having problem with his internet connection. Let us wait for a very short time so that Dr. AIDA will be able to join our session. And in the meantime, until AIDA connects this session, I would like to mention to you that I can see in the chat session Professor Dr. Ateş from Gebze Technical University and Professor Dr. SISWOYO are sharing their emails with each other for further collaboration, which makes us very happy. I think Dr. AIDA has now connected now. He's asking, she is asking if we can hear her voice. Hello, Dr. AIDA. Unfortunately, Dr. AIDA's internet connection may be poor, therefore we are having poor internet connection problems. So may we share a 1 minute, 2 minute introductory video until Dr. AIDA comes back with us.
Catching a bus, never nothing when it's really it does. I'm flying above, no bluffing, no worry, keep it coming, yeah, I'll be saying something. Zipping from Chicago, can you feel the rush? So let's go. Feel the rush, adrenaline running through us.
Yes, we're still having some problems with Dr. AIDA's internet connection. Yes, I think she's coming now. Dr. AIDA is sharing her presentation with me now. So I will be presenting her presentation on the screen to you. And if Dr. AIDA can only join by her mobile phone and she can make her presentation, we can just hear her voice. Is that fine, Dr. AIDA? So she already sent it to me. Dr. AIDA, can you please connect with your mobile phones? Okay, now we can see Dr. AIDA's presentation, but she's asking if we can make the presentation slideshow via Google Meet, but unfortunately we cannot do it this way. Is there a way to hear Dr. AIDA's voice? I can skip the presentation slides for her. Okay, I think we cannot hear Dr. AIDA at all now. So may I suggest, also Dr. AIDA is suggesting that she will make a video recording of her presentation, and then she will send it to us and we will share it with you later. Okay, so I think Professor ADARSH is not with us now as well. Is Professor ADARSH with us? Okay, unfortunately we don't have Professor ADARSH with us as well. So then I may suggest this is the end of day 3, room 1, session 3, and I hope to meet you in the next session. Thank you very much for being with us.
Catching a bus, never nothing when it's real, yeah.